2.15, factoring with greatest common factor and grouping method. For this video, we will only be covering factoring with the greatest common factor. For the grouping method, please refer to the next video. First, we need to review the distributive property because when we factor, it's the reverse of distributing. So you could say it's the opposite of distributing. For example, if you have 2 parentheses x plus 3 in parentheses, what you're going to do is whatever's in front of the parenthesis, you take that and distribute it to everything inside the parenthesis. So 2 times x gives us our 2x, and 2 times 3 gives us our 6. So if we want to go backwards, we would start with this answer over here that we got when we distributed. And then we would go back to the original problem. And that would be our answer for when you factor. So first, to factor this, what we would do is first say, well, we need to find the greatest common factor. What's the greatest common factor? Between 2 and 6, the greatest common factor is 2, because 2 divides evenly into both of these numbers and has a remainder of 0. For example, 2 divided by itself, 2 divided by 2 is 1, the remainder is 0. 6 divided by 2 is 3, remainder 0. So this is your greatest common factor right here. And then what you do, I know the answer is already up here or over here, then what you do is you say, what do we need here times 2 to get back 2x? Well, we would need an x. And then what would we need here to multiply by 2 to get back a 6? We would need a positive 3. So that's how you do your factoring. And this would be your answer if you were asked to factor this expression right here. Okay, so let's factor this one. Let's pretend we don't have the answer here. Scribble that out for a minute. So first you need to find the greatest common factor. Well, 2 will divide evenly into both of these. 4 will divide evenly into both of these. But you need the greatest common factor. So the greatest common factor for this one is 12. Because 12 will divide into itself 1 time with the remainder 0, and 12 will divide into 65 times with the remainder of 0. And then you say, all right, well, factoring is the reverse of distributing. So what do I need here times 12 to get back this term? Well, we would need an x, because 12 times x would give us back that. And then what do we need here times 12 to get back this? We would need a negative 5, because a positive 12 times negative 5 gives us back our negative 60. And then that would be our answer. And you can see there's the answer up there as well. All right, let's go ahead and factor this one. Number 1, negative 42n to the 4th minus 30n squared. So to find the greatest common factor, you could probably look at this and just determine what that is. It is a 6, but if you're not sure, what you can do is you can use a factor tree, and you can break down your numbers into their primes. Whoops, that's a 6. What am I doing here? Okay, so 42 is 7 times 6. 7 is a prime, so circle that, and then 6 is 2 times 3. So then rewrite 42 as 2 times 3 times 7, and we'll talk about the negatives in just a minute. Just right now, we're just going to deal with the primes without dealing with the negative sign. And then 30 is just 3 times 10, and then 10 is 2 times 5. So then we have, let's put a little bar separating these. See, we'll have 2 times 3 times 5. And then for the ends, we have 4 ends here. And then we have 2 ends there. So let's figure out the greatest common factor. And again, you can probably, you'll just get to the point where you can just see it. So you don't have to do all of this. But if it's hard for you to see it, then break your numbers down to primes and then write out how many of your variables are being multiplied. So the greatest common factor is going to be what's in common to both. Well, we have a 2 in common and we have a 3 in common. So you circle that. And then what do we have in common with the ends? Well, we have only 2 ends here, and then we have 2 ends here. So the biggest amount of ends in common would be 2, not 4, because the key word is the C. It has to be in common to both. So this has 2 and that has a total of 4. So what's in common would be 2. So the greatest common factor on this one is going to be a 2 and a 3 and 2 n's, which gives us 6n squared. Also, just if you'd like to review how to find the greatest common factor, that's back in 1.8, assignment 1.8. Just if you'd like to go back and review that. Okay, so what we're going to do is we're going to put our greatest common factor here, because again, what you have out in front here, that is your GCF. So this is our GCF. And then you put parentheses and say, well, what do you need here times this to get back this? Okay, so now we need to address this negative here. Anytime your leading coefficient or your leading term has a negative, you also need to factor that out. That's very important. Please make a note of that. I'll highlight this, maybe make it, circle it, make it green. Okay, because I've noticed when you're factoring in the homework assignments, if you don't factor out the negative, then you'll get your problem wrong. Okay, so then you say, what do you need here times negative 6n squared to get back a negative 42n to the 4th? Well, we're going to need a 7, and we have 2 n's here, so we're going to need 2 more n's. So we get a total of 1, 2, 3, 4 n's back. And then what do we need here times 6n squared to get back negative 30n squared? Well, 6 times 5 will give us back 30, and the negative 6 times positive 5 will also give us back 30. So we need a plus there. And when you multiply, you distribute this n squared here. Those 2 n's will come along, so we'll get back all of this. So our final answer is negative 6n squared times 7n squared plus 5. And factoring is just the reverse of distributing. So to check, you would just distribute, and I always double check. Does this times this give us back this? Yes. Does negative 6n squared times 5 give us back this? Yeah. So therefore we have the correct answer. And then you can just box this. All right, let's go ahead and do this last problem down here. Let's see here. Let's scroll down or scroll up, whatever. All right, so we have 24, 30, and 45. We need to find the greatest common factor between those 3 numbers. So 24, that's just 8 times 3, so you can do 2 times 2 times 2 times 3. And then 30, that's just 6 times 5, or 2 times 3 times 5. And then 45 is just 9 times 5, just 3 times 3 times 5. Now, if you need to do your factor trees to get your primes, that's fine. Just make sure when you multiply all of these, you're getting back your original numbers. Because if you leave one off, then if I left a 2 off here, I'd get back 12, not 24. And then here we have 6 m's. 1, 2, 3, 5, 6, and there we have 4. 1, 2, 3, 4, and here we have 3. Okay, so for the greatest common factor, we have, let's see, everybody has a, nope, everybody does not have a 2. Let's see, does everybody have a 3? Yep, everybody has a 3. Does everybody have a 5? Nope. So the only thing in common is 3 for your numbers. Now for your variables, what's the greatest amount of m's multiplied that's in common? So it would have to be 3. Everybody has 3 m's. So your greatest common factor is going to be 3 and 3 m's. All right, so we're going to use that to factor this here. So again, you always put your greatest common factor out in front, and then just do a parenthesis and leave things blank. So we're going to have 3 slots for each one. So what do we need here times 3m cubed to get back this one? Let's see, well, we're going to need 3 times 8 is going to give us back 24, and then we only have 3 m's here. It looks kind of sloppy. Let me fix that. Oops. Try again. Okay, so we have 3 m's here, and we're going to need a total of 6, so we're going to need 3 more m's back. Then what do we need here times 3m cubed to get back this one? We'll need a negative 10, because 3 times negative 10 will give us negative 30, and then we'll need 1 more m to get a total of 4. 1, 2, 3, 4. And for the last one, 3 times negative 15 will get us back 45. And when you multiply that, we'll get back our 3 m's as well. So the final answer is 3m cubed times 8m cubed, subtract 10m minus 15.